All right, welcome today to our lesson on finding the midpoint of a line segment. Our essential question today is how do we determine the exact midpoint of a line on a coordinate plane? So you'll notice that we're actually going back to a standard we've covered already just because we're just going further in depth with a concept that you'll find often on standardized tests, which is finding the midpoint. Still use Desmos as a resource always while we're on the coordinate plane. All right, let's do a little warm up here. So line segment AB is shown. They want us to find the midpoint. Okay, so here's A, here's B, let's say. So what we want is the line that's in the exact middle, right? Okay, I want to show you a visual way how to do this just so we understand the concept. If we want to think of a line that's in the middle, you could think of, well, what's the middle of this horizontal distance? What's the very middle of that? And you could just count it if you want. 1, 2, 3, 4, 5, 6, 7, 8. So if I just go 4, that's the middle of this line. So if that's the middle, and then I go up, that'll lead us to the midpoint. So by just using kind of a visual method, if I count where this point is, it looks like it's at 6, 7. Okay, so just going through like a visual method. And if you wanted to do the y-axis as well, you could. The middle of this line is this right here, right? So it's literally finding the middle of this line segment, and you could find it by finding the middle of the horizontal and the vertical distance. Now, of course, we don't want to just rely on a visual method. We want to have a way to do it mathematically, especially, if the numbers get larger or if they're not so clean and even. So what I want you to think about is finding the midpoint is like finding the average of each coordinate. So what we're going to do is we're going to find the average, in other words, the number in the middle between 2 and 10. So the easiest way to do this is to add them up and divide by 2. So 12 divided by 2, that's 6. And then we'll do the same thing for the y-coordinates. 2 plus 12 divided by 2. So that's 14 over 2, and that's 7. And notice that's the same point we got when we did it using the graph. So 6, 7 is the midpoint. For your notes now, the midpoint is the exact middle of a line segment. You probably knew that part already. The midpoint of a line segment on a coordinate plane can be found by taking the average of the endpoints. That's really the key idea. And then if we want to put a actual formula on it, this is the midpoint formula. You take the x values, you add them up, and you divide by 2. And then you take the y values, you add those up and divide by 2, which is the same thing as finding the average. Okay, let's do a practice one. I think you should pause it here and try to do this one here on your own. All right, and I'll take you through it here to make sure you did it correctly. So what I would do here is I would still recommend that you label your points x1, y1, x2, y2, just to keep yourself organized. And so our midpoint here is going to be 3 plus -8 divided by 2. And then on our other point, it's going to be 5 plus -11 divided by 2. So I just need to simplify both of those expressions. So it's going to be 3 plus -8. That's like 3 minus 8. So -5 over 2. And then 5 minus 11. That's like -6 over 2. So what's that going to equal? We're going to have -5 over 2. You could leave it like that if you want, -5 over 2. Or you could call it -2.5. And then -6 over 2, which is -3. Okay, you'll notice here, you don't always get whole numbers, right? A midpoint can be any point. So sometimes you're going to have a decimal, or we could have left it as a fraction. But that's the middle of that line. All right, now let's try a slightly more complex problem where we have to find the endpoint of a line segment when we're given the midpoint. So here we go. We have a line segment AB on a coordinate plane. And I'm going to sketch this situation just so we kind of have a visual. So let's say A is here at -4, 5, right? And then they tell you where the midpoint is. M is the midpoint. So M is up here. We'll draw it up here. M is up here at 14, -6. And then B is over here. And this is what we don't know, right? This is what we're trying to figure out. Now, I didn't draw this to scale. I just gave you a little visual to map it out. But what we're trying to figure out is what are the points of B? What's the location of B? So we have a couple options here. The first thing we can do is we can just use the midpoint formula in reverse. So let's think about the x coordinates here, and let's see how we would set this up. So if you think of like the first point being x1 and y1, What we don't know is x2 and y2 for the second point. So you can think about solving the midpoint formula for x2. So here's how that would look. You would have negative 4 plus x2, so the unknown x coordinate of b, divided by 2, would have to equal 14, because that's the x coordinate of the midpoint. So we can solve this equation using inverse operations. So we'll multiply by 2 on both sides, right? So we have negative 4 plus x2 equals 28. Add 4 to both sides. So x2 is going to equal 32. All right, and that's a reasonable answer, because if you have 32 and you add it to negative 4 and divide by 2, you get 14. Why don't you pause it here and try to do the same thing with the y coordinates? Okay, the answer you should have gotten was negative 17. And if you did the algebraic way, that's great. I want to show you another way you could do it, just so you can see that there are multiple options. So here's another way you could think about this. Check this out. You could think of it this way. You could say, all right, 5 to negative 6. Sorry, not 16, to negative 6. What's the distance between those two numbers? How do you get from 5 to negative 6? Well, you have to subtract by 11, right? So since negative 6 is right in the middle, if you subtract by negative 11 again, you're going to get to that point that you need for point B. So you could say negative 6 minus negative 11, well, that is negative 17. So that's just another, maybe slightly quicker way to get to the right answer. Either way, you're doing it right, whether you use the algebraic way or if you just think about the distance between those numbers, since the midpoint is the number that's exactly in the middle. And as always, it's a good idea to pop these things into Desmos and just make sure it makes sense visually. As you can see, these are pretty spread apart, but our point 14, negative 6 looks like it's about in the middle of 32, negative 17. And you could even, if you wanted to, you could count it out and show that those distances are exactly the same. But it's a good idea to check. Okay, let's do a quick review as we get into a little bit more of an advanced mode here. So let's remember what a midsegment is. So a midsegment is the segment that connects the midpoints of two sides of a triangle. So here our midsegment is DE, right? So we have triangle, say we have triangle ACB here, right? DE is the midsegment because it's the line that connects the two midpoints. And then the key thing we want to remember are its two qualities right here. So the midsegment is always parallel and half of the length of the third side. So here's 8, here's 16. The midsegment's always going to be half, and it's parallel to that. What we could do then now with this information is we could now prove these qualities on a coordinate plane. Since we have these skills, we can now prove them on the coordinate plane. So let's do this first. Determine the points of a midsegment of ABC by finding the midpoints of AB and BC. So let's do that together really quick. So we want to find the midpoint of AB. So let's say midpoint of AB is going to be negative 6 plus negative 1 divided by 2. So that's going to be negative 7 over 2. You can leave it as negative 7 over 2. You could call it negative 3.5. And then you've got 6 plus negative 2 over 2 equals 4 over 2. So that's 2. So that means if we go to negative 3.5, 2, right about there, that's our first point. Let's call that x. Okay, so negative 3.5, 2, that's x. And then let's do the same thing for BC. So BC is going to be at the midpoint of these 2 points. Why don't you pause here and figure that one out on your own. All right, and the answer you should have got here was 0.5, 3.5. And I'm calling that point y. So if you connect x, y together, that would be your midsegment. And you can see, just based on this very rough sketch, that this segment looks to be about half the length and is parallel to line segment AC. Now, looks to be is not quite enough, as you know. We want to prove that this is actually the case, right? So let's get these back on the screen, these midpoints. Okay, those are on the screen now. And I think a good place to start here is let's actually figure out the length and the slope of AC, since that's what we're trying to compare this to. So let's do the length and the slope of AC. So this is review from what we learned before, so I'm going to go over this a little quickly. But if we want to do the slope, we could do 1 minus negative 2 over 2 minus negative 6, right? So we're going to have 3 over 8. Okay, so that's the slope we're looking for, 3/8. And then if we do the distance, we could apply the distance formula, right? Let's apply the distance formula. So we would have 2 minus negative 6 squared plus 1 minus negative 2 squared. All right, we're simplifying now, so we have 8 squared plus 3 squared, and that's going to be 64 plus 9, so that's going to be the square root of 73. Okay, so this is the slope and the length of AC. So we want to compare this to the slope and the length of XY. Okay, so now what we want to do is we want to find the slope and length of this midsegment XY. So just so we can remember our work we did on the last problem, the slope of AC was 3 over 8, and then the distance of AC was the square root of 73. So remember, if this is the midsegment, we're trying to prove that our line XY, our midsegment, is parallel and half the length of AC. So let's start with the parallel part. Parallel part means they should have the same slope. So let's find the slope of XY. So we're going to have 3.5 minus 2 over 0.5 minus negative 3.5. All right, so we're going to have 1.5 over 4. Okay, now, that may not look like the same slope right now, but notice we have a weird decimal here. So let's get rid of the decimal. Let's multiply both sides by 2. If you multiply both the top and the bottom by 2, you're not changing the value of the fraction, but you'll notice that you end up getting 3/8. So that's mathematical proof that these two lines are parallel, right? Because they had the exact same slope. Now let's do the distance part. Now we're looking to show that the distance is half the length. So the distance formula. And again, expect decimals here because we're going to get some kind of weird answers. So we have 0.5 minus negative 3.5 squared plus 3.5 minus 2 squared. I don't know if you guys noticed this, but it's the same values you're using up here from the slope formula. And then you get 4 squared plus 1.5 squared. All right, and then using my calculator here, that's going to be 4 squared is 16, 1.5 squared is 2.25. So we have the square root of 18.25. Okay, now again, you have to look at this deeply, right? Because this may not look like it's half of this, but we can check if we actually plug these values into our calculator. So the square root of 18.25 is approximately 4.27. And then the square root of 73 is approximately 8.54. So again, this is mathematical proof that our midsegment is exactly half the length of the line that it faces and parallel to it as well. All right, that's all for today. Here's some extra practice opportunities which are linked to this YouTube video if you want to practice more or know more about this. And you're now ready for the exit ticket. Good luck.